Okay, chapter 1, section 2, multiplying rational numbers. So this section is about getting comfortable with timesing whole numbers, fractions, and decimals. So before we go over it, I wanted to do a quick review of adding fractions. Now, when we add fractions, we need a common denominator. And the reason why we need a common denominator is because that makes all of the pieces the same size. So when we combine them, we can say, okay, we have this many of them. So the pieces need to be the same size. Because we have a common denominator by getting a common denominator. So when we're adding fractions, if I have something like 1/8 plus 1/8 plus 1/8, when I combine those, I haven't changed the size of my piece. So it's still an 8 on the bottom, but I have changed how many I have. And so when I add them, I just do what it tells me to do on top. 1 plus 1 plus 1 is 3. So because multiplication is repeated addition, I can just ask myself, well, how many times did I add 1/8? Well, I added 1/8 3 times. So this is going to work out to be what we're really working with. And when I take a whole number and I times it by a fraction, what I want to do is I want to get this whole number into a fraction because it's the easiest thing to do. And I can take any number and put it into a fraction by putting it over 1. By putting it over 1. So 3 I can make into a fraction by putting it over 1, and then multiplying is great because you really just go straight across the top, straight across the bottom. It's going to give us 3 times 1 is 3. 1 times 8 is 8, giving us that exact same thing that we got up here when we repeatedly added them. In multiplying rational numbers, remember, our integers are positive and negative. So I want to go over what makes it positive versus what makes it negative when we're talking about our signs. Now, if we have an even number of negative signs, our answer will be positive. If we have an odd number of negative signs, our answer will be negative. Let me show you why. So if we start out with a number line and we have 0, then everything to the right of it is going to be positive, and everything to the left of it is going to be negative. Well, we've multiplied positive numbers before, something like 1 and 4, we know we get that positive 4. So if we don't have any negatives, so 0 negative numbers is going to be a positive number. Now, the minute we put a negative number in there is the minute that something has to change. Well, it can no longer be a positive number, so it has to come back over here to the negative side, and it is a negative number now. So now it becomes negative 4. Once you add another negative, well, it can no longer be a negative because we've changed it. So now it has to come back over here to the positive side, and we have 2 negatives making it a positive. Some people even will even do something like 1 negative, 2 negatives, 3 negatives, 4 negatives, 5 negatives, 6 negatives, 7 negative, 8 negative, 9 negative, and whatever one they land on, that's going to be the sign of their answer. If they had an even number, they would have landed on a positive, and that would have been the sign of their number. That's totally okay. I like to think of it like this, and I can count it in my head. And if there's an even number of negatives, it's a positive. If there's an odd number of negatives, it's a negative. So the first thing in the book that it talks about is multiplying a fraction and an integer, which we kind of talked about up here in our little review. By an integer, it just means a whole number this time. It could be a positive number, it could be a negative number. We'll deal with both. So the first one, 6 2/3. I can turn this 6 into a fraction just like I did up here. I can turn any number into a fraction just by putting it over 1. From here, I go straight across the top, straight across the bottom. 6 times 2 is 12. 1 times 3 is 4. 1 times 3 is 3. My answer when I reduce it, because it is just a division problem, 12 divided by 3 is 4. All right? Now, in order to not have to simplify it over here, there's a method that's called cross-canceling. So if I started with 6 2/3, what I can do is say, all right, I'm putting my 6 over 1. Is there anything on top that is going to cancel out, cross-canceling, crossing against the top and the bottom, with anything on bottom? Well, I see that I have a 6 and a 3. They share a factor. The factor that they share is 3. So if I divide that by 3, and if I divide this by 3, I know 6 divided by 3 is 2. So I now have 2 there, and I'm no longer working with that. And 3 divided by 3 is 1. So I have that there, and I'm no longer working with that. I get 2 times 2 is 4 over 1 times 1 is 1, and anything over 1 is really just that whole number. So either way, if cross-canceling is easier for you, go ahead and do it. If this makes more sense and you can just simplify in the end, you can go ahead and do that. You're gonna do a couple of them.